Welcome back to the deep dive. Today we're doing a different kind of risk assessment.
Hmm.
We're not talking about hardware failures or system vulnerabilities. We're looking at a source of failure that's, well, it's probably sitting on your shelf right now in your instruction manuals.
Right. And we have to stop thinking about standard English as just, a communication tool.
And start seeing it for what it is in our world.
Hmm.
A deeply flawed engineering tool, one that's actively creating risk in mission-critical operations.
That is the crucial reframing,
Hmm,
especially for the engineering directors and operations managers listening. Ambiguity is great in literature, right? It's a feature.
sure, it encourages interpretation.
But when you are directing a maintenance procedure on, say, a piece of high-stakes industrial equipment,
Hmm.
ambiguity is not a feature. It's a measurable source of technical debt. It's risk.
So that's our topic today, semantic engineering, viewing language precision as really a core part of operational safety and risk management. Our mission for this deep dive is to conduct a forensic examination of this. We'll look at the linguistic ambiguity, the real operational costs, this invisible friction it creates, and then lay out the rigorous engineered solution.
If you're responsible for uptime, for safety, for managing global teams, you really need to understand why your manuals might be putting your operations in jeopardy without you even knowing it.
Okay, so let's start with this paradox of standard English. We always boast about its size. Its vocabulary is, what, something like 3 times larger than German or French?
It is. And that richness is wonderful for writing a novel. But for operations, that richness, that sprawl of synonyms, it's a monumental bug.
A bug. How so?
Well, when you have 5 different words to say the same thing, you've just introduced 5 ways for that instruction to be misinterpreted.
I see.
Ambiguity stops being the exception. It becomes the default rule. And that complexity just builds unquantifiable technical debt into every single manual you produce.
Okay, let's bring this down from the abstract to the factory floor. Give me a concrete example.
Let's take the simplest, most common instruction imaginable. Just 2 words. Replace the gasket.
Replace the gasket. Seems pretty clear to me.
It feels clear to the writer sitting in their office.
Yeah.
But for the engineer on the ground, maybe English is their second language, that phrase creates a gambling scenario. They have to stop.
Stop and ask what?
They have to ask, does replace literally mean take the old one out, clean it, and put it back in its place? Or does it mean discard the old part and fit a new identical one?
And the consequences of that guess could be huge. We're talking about safety, leak tolerance.
Precisely. And the language itself failed to capture the intent. This is where it gets interesting when you compare it to other languages.
Like German, you mentioned.
Right. In German, you'd use 2 different verbs. You'd use ersetzen, if you mean swap it for a new part. Or you might use wieder einbauen, literally to rebuild or reinstall, if you mean put the old one back.
So the language itself forces precision.
The linguistic structure of English allows replace to cover both, forcing the team to pause, to research, or worst of all, to guess.
And that pause, that guess, that's a liability.
It's a liability that turns into real, quantifiable business cost. Which brings us to this idea of operational friction.
Operational friction. I like that term. It sounds abstract, but it's very, very real. It's that invisible downtime, isn't it? It's the moment a qualified technician stops working, that hesitation, that need to call a supervisor because the command is ambiguous.
And with global teams, where English is often a second language, that friction just gets amplified massively. We can actually model it.
It's not just wasted time then.
No. It shows up in the data. Increased mean time to repair, higher error rates in the logs, more documentation queries. Think about an aircraft on the tarmac, a stalled manufacturing line. All because an engineer sees a phrase like left engine switch.
Okay, I can see the ambiguity there.
Right. Is it the switch for the left engine, or is it the leftmost physical switch on the panel?
And that hesitation scaled across a whole year.
That translates directly into lost revenue. But it gets worse.
How so?
The cost of friction is high, but the cost of a safety failure is catastrophic. Now we're talking about critical safety exposure. Regulators mandate that you plan for not just intended use, but also reasonably foreseeable misuse.
And vague instructions are basically an invitation for foreseeable misuse.
Exactly. And the gold standard case for this, or maybe the notorious standard, is the Black & Decker saw bench case.
Ah, yes, that lawsuit. It all came down to the instructions for changing the saw blade. The safety warning was, where was it?
It was the very end of the section. after all the complex physical steps.
And the wording itself was the point of failure.
The exact sentence was, before attempting any of the above operations, the power should have been switched off.
Okay, let's do a forensic analysis of that phrase, because there's so much wrong with it. First, the placement. It's at the bottom. Easy to miss.
Very easy to miss. But second, and this is the critical part, is the linguistic structure. It uses passive voice. And that soft modal should have been.
It's not a command.
It's not a command. It sounds like a polite suggestion, a best practice. When you're writing for a machine that can cause serious injury, you cannot be polite or suggestive.
You need a direct, unambiguous command.
Yes. And that linguistic failure was a key reason for the injury, which led to multi-million-dollar liabilities. The document itself created a foreseeable risk.
So if the problem is baked into standard English, what's the engineered solution? Where do we turn?
The solution is a methodology designed specifically for this. It's called Simplified Technical English, or ASD CE 100.
ASD.
Aerospace and Defense. It was born in those industries because, for them, ambiguity leads to billion-dollar failures or, tragically, loss of life. STE is how you control language in high-stakes environments.
And this isn't just a style guide, is it? It's more fundamental than that.
It's a structural limitation on the language. It works with a two-pronged strategy. First, there's the core vocabulary.
Okay.
It's a strictly controlled dictionary of about 930 approved words. If a word isn't on that list, you can't use it, period.
930 words. That sounds incredibly restrictive. How can you describe a jet engine with so few words?
It actually enforces accuracy. Because the key is, each of those 930 words is limited to one, and only one, technical meaning.
Give me an example.
Take the word close. In English, you can close a door, close a debate, close an account. In STE, close has one meaning: to move a switch or a valve to the closed position.
So if you want to shut a door.
You have to use the STE-approved word, which might be shut. It eliminates the need for interpretation from the very start. It forces the writer to be precise.
Okay, so that's the vocabulary. What's the second part?
That's the set of 65 writing rules. These rules strip out ambiguity. They forbid turning verbs into nouns, they limit sentence length, and most importantly, they ban those modal words that imply choice.
Modal words like?
Words like shall, may, can, might. In a normal manual, the operator may check the pressure is fine.
But it's optional.
It implies an option. STE forbids that. You must write the direct command, check the pressure. Or, if it is truly optional, you have to be explicit. You can check the pressure, IF, and then state the condition.
It kills the gray area.
It completely eliminates it. You can't write the adjustment ought to be performed.
Which goes right back to the Black & Decker case. Instead of the power should have been switched off.
STE forces the writer to use the direct, immediate command. Switch off the power.
That's the power of engineered language. And I imagine there's a huge benefit when it comes to translation as well.
A massive financial benefit. Because the source English is so simple and unambiguous, translation is faster, cheaper, and has far fewer errors. It cuts your global operational costs.
Okay, so for the leaders listening, the next question is obviously implementation. We're talking about changing the habits of skilled engineers who've used standard English their whole careers.
And you can't do that by just buying the STE spec and emailing it to your team saying, read the rules.
Right. It's a skill set change, not a paperwork exercise. So why is high-quality foundational training so critical for this standard in particular?
Because the goal is mastery, not just exposure. The biggest failure mode when companies try to adopt STE is poor adoption because they do mass low-quality training. People just go back to their old habits.
They need to unlearn decades of writing in a certain way.
Exactly. It's a technical skill that has to be learned and verified. You're adopting a whole new linguistic framework.
So you need a partner who gets that, who understands that precision mastery is everything.
Yes. And when you look globally at the authorities in this very specialized field, one name keeps coming up: Shufrans Tech Docs.
Shufrans Tech Docs.
They've been implementing ASDTE 100 for over 44 years. In aerospace, defense, heavy machinery, medical equipment, the highest stakes environments you can imagine.
And what's really telling, and it connects right back to what you said about mastery, is their training model. They cap their workshops at only 5 participants.
And that's not by accident. That small group size is the secret. It's how they engineer precision into the training itself.
To ensure quality over volume.
To ensure every single person in that room masters the methodology. The instructor can give personalized, intensive feedback. You can't get that level of mastery in a large classroom. It's proof they treat the training with the same rigor as the standard.
So To synthesize this for the engineering director or operations manager listening, ambiguity isn't just a nuisance.
It's operational risk. It's technical debt accumulating in your manuals, and you are paying for it every single time a technician has to pause or hesitate or guess.
And adopting semantic engineering through STE isn't just a documentation project.
It's a fundamental safety and consistency measure. It impacts uptime, compliance, translation costs, everything. The solution is there, but mastery requires a serious, expert-led training strategy.
Which leaves us with a final provocative thought for you to consider. If your company is still operating on the idea that ambiguity is just a normal part of standard English, how much unknown operational friction, how much silent safety risk is building up in your systems right now?
Look at the cost of your current downtime.
Hmm.
And then ask yourself, how much of that is just due to unclear language?